Welcome to SciShow Tangents, the lightly suggestive.
Mamma mia.
The lightly competitive science knowledge showcase. I'm your host, Hank Green, and joining me this week, as always, is science expert Sari Riley.
Hello.
And our resident everyman, Sam Schultz.
Hi.
I want to ask you two a question, and I want you to give me the closest honest answer you can give me. How many tabs do you have open right now?
Oh, I just actually did a tab call. I have
Nice.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I have 25 tabs open.
And you only have one. You only have one thing.
I
You
only have
open?
one window. That was the call. I collapsed them all into one window.
Nice.
I have 16 tabs across 4 windows, but they're not distributed equally. One of my windows has one.
That's that sweet freelancer lifestyle. Look how few tabs you have open.
Yeah.
I have, as of now, I think 64 tabs, and the vast majority are in one window, and there's one with 10, and there's one with 3.
Is there any kind of method to the 10 and 3?
No,
like, are they
not
something
at all.
different?
Here's the method. I'm selling a lot of, I'm trying to sell socks right now, so it's just all like panic, no time to do anything, and it takes extra time to do the to turn the tabs off, and so it's just like during panic times, you can tell how stressed out I am, how much work I have to do by how much the tabs accumulate.
Is this a lot for you, or like that's a lot? This is a lot for you.
I think I'd say that this is above average. It's certainly
Do you know
not
your
the
record.
Peak. You know, it'd be really cool if Chrome kept track and was like it showed you the amount of tabs that you had over the course of a year.
Yes,
a year in review of Chrome. I would love that.
It's like Spotify splacked, whatever it's called,
wrapped.
Wrapped versus splacked. It wasn't splacked after all.
Yeah, it's a real word and not a fake word that you just made up.
So, well, here it is. For the Chrome engineer listening in the audience, go to your boss with this feature idea. It's called Chrome Splacked, and it shows you all. It will show you. That'd be amazing, actually. Like, how many tabs did you have open? What websites were like the top ones, like Wikipedia, YouTube, Twitter?
That seems sad.
And then at the end of the year, I get to find out what a monster I am.
Yeah.
Yeah. And like fun stats would be which tabs do I open and then close the fastest? Because that's definitely Twitter. Sometimes I just subconsciously start typing it and I'm like, no, I don't want to be here.
I don't care about this.
Or close that tab again.
I was just here 45 seconds ago.
I, for one, cannot wait for Chrome Splacked.
I think it's
me neither.
I think I love it.
Maybe there's a way to sort of like tease it out. Like, it's not like Google doesn't know. Google is very aware of all the websites I went to this year. Well, every week here on SciShow Tangents, we get together to try to one-up, amaze, and delight each other with science facts while also trying to stay on topic and occasionally connect with absolutely stellar features for the Chrome engineering team. Our panelists are playing for glory. We're also playing for Hank Bucks, which I will be awarding as we play. And at the end of the episode, one of you will be crowned the winner. Now, as always, we're going to introduce this week's topic with the traditional science poem. This week, thank God it's not from me because I didn't do it. From Sari.
Let's play I Spy with my little eye and process all the photons that fly right by. That red bird, that yellow-green tree, that fluffy black cat who's staring at me. Our sight doesn't work like touch, taste, or smell. We got proteins called opsins in our rod and cone cells. The light becomes electric for your optic nerve, and your brain eats it up like a yummy hors d'oeuvre. A lot goes on in that squishy gray goop to generate these images of tow trucks or poop. You got shape, color, depth, and movement or distance, facial recognition, or non-existence. Yep, that's right. While some visions are true, we got hallucinations or mirages here too. Cosmic rays causing stars or illusions great and small, not to mention those wavelengths we can't see at all. So if seeing is believing and our sight is what we got, then bees and shrimp and tarsiers live in worlds that we do not. We work with these limitations and do the best we can and strive to make something beautiful for more than just humans.
Oh my gosh.
Yeah, like 25% of the way into your poem, I became aware of my existence in the sort of story of chemicals moving away from being dead. Like, that was like, why to be like, I just sense the world and and experience consciousness because I can interact with space and detect photons. Also 75% of the way through this poem, I thought to myself, we should have a kids show where Sari writes kids songs about science.
Yeah.
That's my dream. Can we reboot Schoolhouse Rock?
Oh my God.
I would love to be the guy who
can.
does Schoolhouse Rock.
I mean, Sari, there is literally no one else who would be more capable of rebooting Schoolhouse Rock than us.
I'm also the producer of a children's show.
Yeah.
Could
so
just,
we're there. I got a bunch of nerds who like to watch my content who keep popping out babies. Oh Lord. So the topic for the week is sight. Wow, is really off topic, but I'm excited about our new project. And sight is any way of detecting photons?
I think so. I think
or is it like what about like heat detection, like pit organs?
Oh yeah.
Is that kind of sight? Because it's infrared photons.
I think it's in the realm. I think if you drew a big umbrella of everything that could count as sight, then
pit
eyes had to evolve from something.
So yeah, I mean, it's not like you like seeing badly definitely counts as seeing. I'm not saying that eye spots are eyes, but I do think that they are sight. After I said it, I felt apprehensive, but I still feel like I'm right.
If you can tell the differences between light patterns,
and we mean any part of the electromagnetic spectrum there by light, or do we mean confined? Because there's no reason to confine it. I think you have to include all of it. You might as well
if we just say visible light, that's very human centric.
Yeah, totally.
We invented what visible light was because we were like, that's what we can see.
Well, honestly, I think that is surprisingly, there's a fairly clear line that you can draw around that. Like it's detecting photons in the electromagnetic spectrum. Sari, can you tell us anything about where sight comes from etymologically?
A little bit. It seems like it is fairly straightforward in that a lot of the Germanic roots of the word sight relate to words that sound like see, which makes sense.
Yeah.
The mystery, I guess, is where see came from, because there are probably a lot of, we still have a lot of words for to observe or to see or like vision, sight, all these different things that mean observing the world around you. And so we're not entirely sure where the word see comes from. It could come from a root that has to do with like to follow, as in like you are following something with your eyes and then you are seeing it. It could just have to do with a word for eyes, like the word eye. If you trace it back far enough, sounds kind of like the word see if you just add an S on it, like see eye. And then that's about it.
Just another one of those caveman words.
Yeah, it goes deep. And that means that it's time to move on to the quiz portion of our show. So the world only looks like what our eyes say it looks like. Everything from the colors that we are able to see to the distances that we can process are based on how our eyes work and how they relay information to our brains. So if you asked different animals what the world looked like to them, you would get a lot of different answers because there are many different ways to see out of many different types of eyes. So the following are 3 stories of animal vision, but only one of them is true. You're going to have to tell me which one is true, and I'm going to start now. So mantis shrimp, we all know mantis shrimp got weird eyes. They can see a wide array of colors, but it turns out that they can also see non-colors. Scientists have found proteins in the mantis shrimp's eyes that react with chemicals associated with fish smells, helping them visualize the location of their next meal. Their eyes can not just sense photons, but also chemicals. Well, that might not be true. It might be this one. Snakes don't have great vision, but some species are able to improve their sight when threatened by restricting the amount of blood that flows to structures around the eye, so that the vision is less obstructed by blood. Creepy. Or it could be story number 3. Scallops have up to 200 eyes along the edge of their shells. Did you know that? That's pretty cool. And to change how light hits the pupil, each eye has an eyelid-like structure embedded with a crystalline array. Opening and closing the eyelid changes the focus of light reaching the scallop's eye so that it can get a clearer image. So, is it story number 1? Mantis shrimp can see smells using olfactory receptors connected to their eyes. Story number 2, snakes can improve their vision by controlling the blood flow to their eyes. Or story number 3, scallops have a crystal eyelid to focus light onto their iris.
Doesn't everything improve their vision by controlling blood flow to their eyes? Is that how like the contracting works?
And that's muscle.
It's not blood doesn't have any part of that. This isn't a trick of some sort.
Blood's doing all its blood work. So in this case, I think the snake story is that there's like blood vessels in the eye, and they don't like want as much blood in the retina area. I
drain
think,
it out.
And so it's just like just hold the blood back for a second while I try and see better.
I don't know. That makes sense to me because if you're focused, I don't know. It's like you want to control your heart rate. Like you're in a tense situation and you're like, okay, calm down. I want to look for a second. And that feels like something that would be possible.
Mm-hmm.
If I was programming a snake in a video game, I'd be like, yeah, we get the soup, the blood's pumping, and then there's a moment where we can have sharp vision and pause our blood for just a fraction of a second.
What are you talking about?
I don't know.
Okay.
I'm just saying it makes logical sense. If I made a snake simulator, I would put that in there.
That would be like a tech tree that you could like put points into. The blood eye.
Oh, man.
Yes. Go into snake vision. I get you now. The mantis shrimp one is like in a cartoon when there's like a smell coming off a pie and it like pokes the person on the shoulder and then it's like doot, 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 and then you float with the So I think that's fake.
It's too cartoony.
Yeah. And I don't know if scallops are like articulated enough to have a crystal eyelid.
I know that they have eyes, but that's not the fact. And I think those eyes are like crystal-y-ish, like they're hard.
Definitely like guys with rock eyes, right? Like
yeah, because they got to be tough if they're going to be facing out into the ocean, and you can't. And I feel like a scallop
to come get your eyes.
I'm only about 60% sure of what a scallop is. Also, is it kind of like a clam?
It's like a clam, yeah.
Okay,
it's the kind of clam. It's like the clam shell that like Ariel has on her bikini.
They're what you give the otter in Animal Crossing when you're swimming.
Exactly. Yeah.
Okay. Okay. That's very clear to me. I think it's got to be the snake thing. I think Sari is exactly right. If it was a snake video game, that's the snake power a snake would have.
I think it's a snake thing too. I would be shocked if it was either of the other two.
Well, you're both right.
Yay!
Wow,
be a little happier about it. You got me.
Well, I kind of felt bad. I kind of felt bad for you, actually. In a moment.
Well, there's lots of cool stuff built into the other facts. So mantis shrimp do have a set of amino acids in their eyes called mycosporine-like amino acids. And they're usually found in the skin of marine organisms as a way to protect cells from UV light. But in the mantis shrimp eyes, they're used as a filter that help tune out wavelengths of light that reach each different color receptor to help pick out particular colors. So it's one of the, I think one of the ways that they see all the different colors that they can see. And scallops, you are right. They have weird rock eyes. They have a bunch of tiny eyes on their shell that are super weird and complex. So light passes through a pupil and a lens and a retina before reaching a curved mirror at the back of the eye, which is made out of guanine crystals. And the mirror sends the light to the receptor on the retinas, which then sends the signal on nerve cells controlled by other parts of the scallops, which then sends that sends the signals to nerve cells that control other parts of the scallop's movement and behavior.
Is it in the shell? Wait,
it's
is it in the shell?
It's on like the rim of the shell.
And it connects to the blob inside.
Yeah. Yeah.
Whoa. I didn't know they...
So like clams, it just doesn't seem like, because they're hard all the way around for some reason, it doesn't seem to me like they are animals.
They are rocks though.
Yeah, they just seem like rocks, but they're like, there's like a living thing in there. So scientists were curious about how scallops are able to focus light, and they realized that while scallops don't have irises like we do, their pupils can open and contract. So that's really a thing, and that changes the shape of the cells in the cornea. So super cool and weird.
That's
but
wild.
They don't have an eyelid. I don't have a crystal eyelid, unfortunately for me. But the coach whip snake is a non-venomous snake found throughout the US and Mexico. And like other snakes, it doesn't have an eyelid, but they do have a thin scale over the eye called a spectacle. And as researchers studied the coach whip spectacle, they realized that there were blood vessels within the spectacle that would expand and constrict to make sure that the blood cells didn't crowd out the vision of the snake. So it's not in the retina; it's actually in the scale over the eye. The cycles of expanding and constricting are regular, but there are a few cases where the snake will intentionally regulate blood flow to accommodate for things like if the snake is shedding, the blood vessels will stay dilated to help support the growth of the new cells. And when the snake feels threatened, it'll constrict the blood flow for several minutes to lower the amount of blood so that they can see better what's going on.
Wow. They're living contact lenses, basically.
Yeah.
Is that what they... Yeah.
I love that it's called a spectacle. It's just such a definite. That is a good instance of a human naming it and being like, oh, you got a little eyeglass there. Oh, a little spectacle.
Yeah, it's wild. Like when you have to like dig through the dirt and you don't have eyelids, you do have to have
something there,
a protective covering over your eye that's replaceable, which is wild. That they do that, so they just shed them after they've used them for long enough. Here it is. Okay. That's not it.
We're going to comb through your 60-something tabs, huh?
I had it in another window. So that means that Sam and Sari are tied with 1. Next up, we're going to take a short break, and then we'll be back for the Fact Off. Welcome back, everybody. It's time for the Fact Off. Our panelists have brought science facts to present to me in an attempt to blow my mind. And after they have presented the facts, I will judge them and I will award Hank Bucks any way I see fit. But to decide who goes first, I have a trivia question that you can try and answer. Some of the largest animal eyes that humans have found come from squids. Living up to its name, the colossal squid has what might be the largest eyes in the history of the animal kingdom. So not just now, but in all time. How large is the diameter of the colossal squid's eye?
Oh. The part of my brain that knows how big like measurements are is not there. This is
you don't have it's not like it's currently inaccessible, but it's never been there.
It's never been there. How big is a basketball?
I'd say a basketball is about 10 inches.
A foot? Yeah.
Basketball.
That was too big. Whatever you were just doing, Sam, was too big.
That's what I'm going with. 10. I'm going with 11 inches.
11 inches?
Yeah.
Okay. I think it's smaller than that. I think I could grab it in a fist. I think I could be an eyeball.
And then pluck its eyeball right out of its head. Some people could palm a basketball, Sari. So...
Yeah, not me though. I'm saying me specifically could reach in, grab that little squid eye, pull it out. So I'm going to say...
It's the biggest eye ever, though, Sari. The biggest eye ever.
5 inches.
How big their eyes
It's
are.
big. That's big. I can't imagine another thing with the eye this big.
Look,
that's pathetic. If it's that big, I'm going to be sad.
I don't have the answer in front of me right now. I'm going to have it shortly, but it wasn't in the doc and Tuna's pasting it in. But I just got to tell you, that's definitely like they're definitely bigger than what Sam said. That it's so big. You got it. They're like deep down where it's very dark. So it's not just that they're big; it's that they need to collect the tiny amount of light.
Eye.
So they just got what is it though? Did Tuna paste it in? 10.629 inches. Oh, so it is about the size of a basketball.
Okay,
look, I know.
Sari Riley would need 2 hands.
But some of the world's best basketball players could absolutely pull out the eye with just their hands.
And you know what? People pay a lot of money to see that.
That's sport.
That's sport. Oh, man. I was shocked to find that a basketball is, in fact, 9.5 inches, and that I was quite close on that.
You're great at, you know everything about basketball. I know everything about squid eyes. We're quite a pair.
I had a friend once who was a giant squid, and he often talked about how big his eyes were.
And then Shaq dunked his eyeball, and that was the end of him.
And now he's dead. So that means that Sam gets to decide who goes first.
I want to go first. I just want to get it over with. Plants are great. They grow fruits and vegetables. They make flowers. They make our air cleaner. They have so many talents, but they simply don't have eyes. A tree can't see its neighbors. A flower can't see the bee taking a drink of its nectar. That's just the way it is. But a plucky climbing vine called Bocchila trifoliolata might change everything we think we know about plants forever or something. Do you already know this?
Uh-huh.
Oh,
I do.
hate you.
But Sam,
Okay.
it is one of the best science facts. And I almost brought it up early in the episode, and I was like, it might be one of the fact off facts.
Yeah.
Because this is the weirdest thing. So I completely agree that it is a fantastic fact. And it is a big question mark in my own mind. But continue.
Bocchila is, like I said, a type of vine with the special ability to mimic the leaves of trees it climbs. In pictures that I've seen, it copies the shape and color of the tree leaves, and one vine can even have several different shapes of leaf on it, depending on like where it's growing. If it's growing on the ground and then up, it'll just have different leaves. Why it does this isn't super clear, but it's probably a way to avoid predators by either like hedging its bets and having lots of leaves and hoping bugs won't think that all of them look tasty, or possibly by attempting to mimic poison leaves. And how it does it is even more unclear. But scientists are on the case. In November 2021, a study showed that Bocchila mimicking a model tree shared similarities in bacterial communities with that tree that it didn't share with Bocchila that wasn't mimicking anything. And another theory is that the plant has a symbiotic relationship with a microscopic organism that steals genes from plants that the vine is growing on and brings them back to the host. But none of this really sounds like it has anything to do with sight so far, huh? Well, in September of 2021, a study was published detailing an experiment where researchers let Bocchila grow on an artificial plant, and Bocchila, I hope I'm saying that word right, I've said it so many times, according to this paper at least, seemed to attempt to mimic the artificial plant that it was growing on.
So it was a plastic plant. It was made out of plastic.
No genes.
So it's not genes. It's not microbiome. It's not
So Bocchila
smell.
leaf is short, ovally. It's a short ovally leaf that ends in 3 points. The fake plant had long leaves that ended in just 1 point. And as the Bocchila grew up the fake plant, its new leaves started to lose their points and got longer and skinnier. Their data also seemed to show that the more Bocchila leaves there were facing the fake plant, the more detailed the mimicry became. This result was shown across all of their Bocchila plants, and the mimicry improved over the course of several months. So the paper concludes
Plant eyes.
with the possibility.
Can see.
The paper concludes with the possibility that these plants can possibly just depend on chemicals or DNA and possibly have some sort of ocelli, which is a simple light-detecting lens that could be helping the Bocchila suss out the shape of nearby plants. And now I've seen pictures of Bocchila in nature mimicking real plants, and I gotta say, they do a way better job of mimicking real plants, which to me suggests that there does seem to be some sort of chemical or bacterial thing happening. But they did at least partially successfully mimic a fake plant, and they knew that there were leaves around even when the leaves are fake. So while scientists haven't really settled on how they pull this mimicry off, I feel comfortable in putting forth my theory that a lot of the information that Bocchila get come from chemicals or DNA, but the vines do indeed seem to have some sort of ability to see. So it looks like we're going to have to add sight to the plant kingdom's already impressive resume, is what I'd say if I was a scientist. I don't actually know, but
I like a little bit of Sam deciding as part of your, like, I'm not saying that I know what I'm talking about, but it seems to me,
as the resident everyman,
it's a lot. It's a lot to do all of those things. So if sight works, why do all the rest? But I guess they're doing a better job in nature. It is wild. What we know for sure, like, it's definitely true that plants can detect, light. So we know that, and and also, like, just the process of doing photosynthesis is kind of like there's clearly like a chemical reaction that occurs because it's hit by a photon. And yeah, so like I heard this news and I was like, 2021, brand new research. Who knows? Like, sometimes stuff is weird. And the big question though I had is, obviously there's a lot of pressure, evolutionary pressure, to do this, because there's lots of parasitic plants that mimic their host tree. But in this case, it doesn't need a particular host tree, and then it developed a way to mimic various host trees. So do you know why it is working so hard to look like, it's not like a tree is going to say, oh, actually, you're my leaf, I shouldn't attack you, because trees can't attack.
I mean, it kind of seemed like they didn't even know why it does it in the first place. So
we don't even know why it does it. It seems like there must be like a pretty strong pressure.
Yeah, it doesn't seem like it's stealing nutrients from the trees, but maybe it is. I don't know. But
yeah,
the articles I read were just like, maybe it's because of bugs. I got to level with you though. Sari gave me that fact, so don't make me sound too smart. Yeah.
Hey Sari, why do you think the bookie was working so hard to hide inside of a tree?
I don't know, bugs.
I mean, I did read a lot of articles about it. She just sent me a sentence that said, hey, this is a pretty cool plant. And I said, oh, cool yeah. Okay.
Yeah, I mean, I can't make a TikTok about that because there's already a viral TikTok about it, which I did very much enjoy. Yeah.
Okay.
But it would be a very good TikTok, as evidenced by the fact that there's a viral TikTok.
Because the fact there already was one.
Yeah.
Damn.
That's not necessarily, that might be a vote in your favor, because it's like guaranteed it is a good fact for a TikTok. Sari, what do you got?
Sight is all about interpreting light in your environment. So, kind of like we were talking about with the colossal squid, if you're trying to see when it's dark outside or dark around you and there's no sunlight, you have way less to work with. And nocturnal animals have found all kinds of ways to supplement their vision with other senses, do mental gymnastics to process the information, or increase the amount of light that reaches their photoreceptors somehow. Kind of like how cats have some reflective tissue tucked behind their retinas called a tapetum lucidum, or colossal squid eyes are just gigantic. But I want to take a closer look at Dinopsis spinosa, aka the ogre-faced spider. Because during the day, they lay flat and pretend to be a twig, which is just wonderful. I wish that could be me. And then at night, they hunt. They're part of a family of net casting spiders. So instead of spinning a big web and then sitting on it, they spin webs between their front legs and actively catch insects with them.
What?
Which explains why they need such good eyesight. They're waving around their leggies. 2 of their 8 eyes are huge and face forward, which is, I guess, where that ogre-faced name came from. And these giant eyes are possibly the largest spider eye on the planet, up to 1.4 millimeters in diameter. Take that, squids. And their lenses can concentrate light really well. But that's not all. Every single night at sunset, as they're spinning their net web between their 2 front legs, these huge eyes synthesize almost entirely new light-sensitive membranes. And then every single morning at dawn, as they're settling into their twig camouflage, those membranes are destroyed again.
What's a light-sensitive membrane?
It's like the equivalent of our retina, but in a spider eye.
Okay.
So
they grow a retina every night.
Yes, they grow, but it's insect eye, it's compound eye, and it's a hexagon. But yes, they grow a retina every night, and then they destroy it in the morning because they don't need it anymore, which is a ridiculous amount of effort. And the only paper I can find that talks about it, which was published in 1978, calls this, quote, cumbersome and, in metabolic terms, extravagant.
Metabolically extravagant is like the best definition of all of humanity, where we're just like, we need to go to the gym. We need to run for no reason.
Yeah.
Metabolic
just
extravagance.
Eat a bunch of food. Yeah. So I love that turn of phrase. Great paper. And apparently this kind of turnover of a photoreceptive thing occurs in a variety of invertebrates, which is news to me, but they do have some guesses as to why these ogre-faced spiders don't keep their good vision during the day. Number 1 is maybe it's just not energy efficient for it to maintain good night vision while it's pretending to be a twig, which they acknowledge isn't a strong guess, but they threw it out anyway because evolution is weird. 2, maybe these light-sensitive membranes are just so unstable that the spiders evolved cellular processes to take care of the wreckage very quickly and regularly and then just rebuild it. Or 3, maybe their eyes would get worse enough over time that it would be just hard to survive and hunt and catch things with their little net legs. And evolution just happened to address this problem by regenerating inner structures every single day. So my conclusion is we may never really know why, but I love learning about metabolically extravagant things because senses just have gone wild in so many different directions, and whatever works for an animal works for them.
Could it be that they're so, I know that I'm just like throwing stuff out here. And maybe you kind of said this, but that like it has to be really sensitive to see in the nighttime.
And they can't close their eyes because they're spiders.
And they can't close their eyes. So like a daytime photons just rip them up.
Ouch.
And so they like, and so they'd need to remake them all the time anyway. So in order to have really sensitive eyes, they've created a structure that can't handle a lot of photons, a lot of energy.
Yeah, I feel like that is a better way to phrase how they phrased in the paper, the unstable one.
That in order to make something that's really sensitive, it's definitionally unstable, or the way that it has evolved to make something very
Yes, whatever biological molecules have gone into this are really good at their job, but only if there is very, very little light.
So even though Sari fed Sam this fact, and even though it's already a viral TikTok, I do know that it's a great TikTok fact because of how it was a viral TikTok. And it's just, it's just the better, like plants can, it's the first evidence we have that plants can see. So Sam has to win.
Now we're talking.
I know, it's not very fair.
In your face, Sari.
I mean, I knew it was a good one. I only give you the good stuff, Sam. I don't try to poison you.
And that means it's time for Ask the Science Couch, where we've got a listener question for our couch of finely honed scientific minds. Sam, what do you got?
The Zinc on Discord asks, why is our site limited to the particular range of EM radiation that it is? Electromagnetic, I assume?
Yeah, I mean, this is interesting. It probably mostly comes down to what is most useful evolutionarily, and that's going to be what light there is to detect on Earth, plus what light was useful for us to have tools to detect. Why is that? I don't know. But now I'm going to let Sari start talking because I was just saying stuff that occurred to me. I was working through it in real time.
No, I mean, that's like basically what researchers have done, but just with more statistics
Cool.
and math applied to it. But then you can also look at genetics to see how our eyes evolved, which is less of figuring out what's optimal and just understanding what actually happened. And then drawing conclusions from there. So around 90 million years ago, way back, primitive mammalian ancestors were nocturnal and could see UV and infrared sensitive. They had like what these researchers called a bichromatic view of the world. So mostly only seeing those ends of the spectrum. And then by around 30 million years ago, our ancestors had evolved 4 different classes of opsin genes, which let them see visible light, except for UV. So there was this shift as mammals went from being nocturnal to being awake more during the daytime, that our genetics changed to stop seeing as much UV and infrared and start seeing visible light as it's being reflected off of objects in the daytime. And of those colors, blue and green sensitivity was the last to evolve. I don't think they've extrapolated why, but it just seems like red sensitive pigments were first in these random mutations. And then at one point, like pretty late in the game, one of those red sensitive pigments became green sensitive all of a sudden. Because that's how evolution works. It's random chance.
Maybe there's just so much green we were like, we don't really need to see that. It's everywhere.
Yeah, but we need to see a berry or something like that. I don't know. The
best thing about evolution to get in to lock in is that like you don't get an ability because it's useful. You get an ability because it's useful and there's a way to get it. Even if you could do it biochemically, if there's not there's not an easy jump. And that's a lot of times what you hear people say about like how could such a complicated structure as an eye itself develop? And the weird thing is that all of this stuff comes from somewhere strange. Like all your little ear bones used to be part of your jaw. Used to be jaw bones.
Took a lot of practice to get.
And then it was like, actually, that's kind of good at like detecting vibrations in the air. And so they'll be better if they're smaller, or if there's a certain arrangement, or if you surround them with certain membranes, and over time you get an ear. It would be really wild if it weren't that way. And whenever I see some fantasy animal with both wings and arms, I'm like, nah, that's not how this works.
Unless the wings are like the thumbs just moved up there.
Yeah, the thumbs like went all the way up the arm onto the back, and now they're wings. The only way for it to happen.
Yeah, you move the sliding scale of like, you can customize faces. Like your eyes can be wider or narrower. So you got to move the thumb all the way up the arm.
So you've been playing a lot of video games lately?
Yes, I have. I have this freelance lifestyle.
If you want to ask the Science Couch your question, you can follow us on Twitter at SciShow Tangents, where we'll tweet out topics for upcoming episodes every week. Or you could join the SciShow Tangents Patreon, and there we have a Discord where you can ask us questions. Thank you to at Magpie Beard, at Robin Han Sopran, and everybody else who asked us your questions for this episode. If you like this show and you want to help us out, it's really easy to do that. And you do like this show, don't you? Because you keep listening, and we keep having a great time.
Keep listening all the time.
Yeah, it's growing. It's a good, happy tangent. First, you can go to patreon.com/SciShowTangents and become a patron and get access to things like our newsletter and our bonus episodes. You can also leave us a review wherever you listen. That helps us know what you like about the show, and it helps other people know what you like about the show. And finally, if you want to show your love for SciShow Tangents, just tell people about us.
Tell people about us.
Thank you for joining us. I've been Hank Green.
I've been Sari Riley.
And I've been Sam Schultz.
SciShow Tangents is created by all of us and produced by Sam Schultz. Our editor is Seth Klicksman. Our story editor is Alex Billow. Our social media organizer is Julia Buzz Bazzaio. Our editorial assistant is Devoki Chakravarti. Our sound design is by Joseph Tuna Medish. Our executive producers are Caitlin Hoffmeister and me, Hank Green. And of course, we couldn't make any of this without our patrons on Patreon. Thank you, and remember, the mind is not a vessel to be filled, but a fire to be lighted. But one more thing. In a 2013 paper, researchers took African clawed frog tadpoles and severed both of the normal optic nerves in their head. But do not worry, those researchers also transplanted a chunk of a chunk of flesh called eye primordia onto their butts, which naturally grew nerves that connected to their spines and sometimes off target to their stomachs. Growing a butt eye is fine, I guess, but a statistically significant number of these tadpoles could actually detect changes in LED light and make behavioral decisions based on those lights. And that indicates that they could see with those butt eyes and interpret that visual information even though they were not connected directly to the brain.
Why did they do this?
I don't know, Sam!
Whose idea was this?
Well, it's interesting, isn't it? They were right.
Yes.
Uh-huh.
Somebody's in the shower and then like, oh, what if we cut their eyes off and put them on their butts? I'm going to go tell my boss that. Fucked up.
Oh my God.